Charging by induction. That involves transferring charge between two objects without touching. So let's look what we have here. We have a neutral conducting sphere. 1, 2, 3, 4 negatives. 1, 2, 3, 4 positives. That's 0. We have an insulator keeping these charges on the sphere and not allowing them to go to ground. But over here, we do have a grounding wire. Okay? This goes right to the ground. This is a symbol for ground. I think earlier we just wrote it as horizontal lines. You can also make it a little more fanciful like this. But right now nothing's happening. We have a neutral sphere, no reason for charge to go anywhere. A negatively charged rod. You can see these negatives, they're vertical, but if you look at it sideways, they're horizontal. You have more negatives than positive, so this is a negatively charged rod. We bring it close to the sphere, but we don't touch. Electrons that were here, remember we have the electrons kind of out like this? They're repelled by the negative charge here, and they do have a place to go. They try and get away from him, and bang, here's a ground wire. They go down into the ground. Once that happens, these guys are no longer here. Actually, this isn't really showing great things, but we now are left with 4 positive charges. So when we charge by induction, we have a negative rod and we leave behind a positive charge on the sphere. The electrons were pushed into the ground. The negatively charged rod over here is kept near the sphere. We then disconnect the ground. Once the ground is disconnected, there can be no more movement of electrons since the sphere is isolated from the ground, both by the air and also by this insulator block. Electrons cannot jump the gap between the rod and the sphere or between the ground and the sphere. The air is acting as an insulator. The rod is then removed. It moves away. Note that the rod's charge did not change at all. It has the same amount of negative charge it had when it began. However, the sphere, which was neutral, now is positively charged. When you charge by induction, an opposite charge is caused on the object you're trying to transfer charge to. Where did the charge come from? Well, it actually gave up electrons to the Earth, so it was left behind with a net positive charge. Let's summarize. Conduction first. You need physical contact between the charging object and the neutral object. So here's our charging object, and we were using a sphere for the neutral. Let's say this started with 2 positives. It touches, and then it's pulled away. Afterwards, the charging rod will have less charge, so let's call it just 1 charge, and the sphere will now gain charge from the rod. Okay, so positive charge has been transferred from the rod to the sphere. Also, a negatively charged object will transfer negative charge to a neutral object. But what stays the same is the total charge. We started with a plus 2Q here, and then after the conduction, we had plus 1Q on the rod, plus 1Q on the sphere, 2Q. Charge is conserved. Induction summary. A charged rod, let's stick with the positive here, will be brought near but not touching a neutral. This neutral, and the key to induction, the neutral object is connected to the ground via conductor. So let's say this positive charged rod is put here, again not touching. Electrons will flow up from the ground to this neutral object, leaving it with the negatively charged. We then remove the ground, put a big X here, just wipe this out. These negative charges have nowhere to go, so this object is left with a negative charge. Your charging rod here didn't gain or lose anybody because there was never any touching here. So actually the total charge of the system is now changing. However, it's getting this extra charge from the Earth, so the total charge, if you include the Earth, this object and the charging rod is conserved. One more detail about induction. Let's keep working with the positive rod here. It comes near the sphere. Let's see if I can draw a better circle this time. Not really. This is connected to the ground. The positive charge rod is brought near but doesn't touch. It picks up, it attracts electrons from the ground, leaving this with a net negative charge. And then we said we disconnect the ground wire. And then we pull the rod away. What if we did the other order? What if we pulled the rod away first? Well, what we would have then is an excess amount of negative charge here. They would have no reason to stay up here. They'd want to get as far away as possible from each other because there's no positive rod attracting them. So all the electrons would flow right back and you'd be left with neutral. You wouldn't put any charge on it. So the important point when you want to charge by induction is remove the ground first and then pull the charging rod away.